Hey guys, today we're going to be setting up top caps on our new Haas VF2SS. It's the first time we've run them, so I gotta cut some soft jaws. So over here, I'm working on my program in Fusion. These are the jaws. They're gonna go on the chip tombstone. Heart sits in there like that. So I have my first toolpath made here. It's just going to rough them out. It'll run for about 10 minutes, so I'm going to go get it set up and let this tool run while I finish programming all the other tools. And what's going to happen is these are my base plate jaws. I'm going to swap these out for a fresh set of jaws, and then we're going to cut what you just saw in Fusion into these. Op 1 on the top cap still gets run on these pallets, so that's nice. This is already set up and ready to go. So Op 2, we just need to cut our fixtures, and then we'll be able to run our top caps on the new machine here. So I'm going to get these swapped out, and then we'll go from there. One thing that's nice about this chip tombstone is there's no bolts holding the soft jaws in, so they literally just click over and pick up. So a ball detent here holds these in place. Makes it really nice for changing jaws out. So again, this just pushes in, picks up, which is awesome. And then what I'm going to do, blow these off. Blow that off, make sure there's nothing in the way here. Grab my new ones. That sits on there. I don't know if I can clip this by hand. Snaps into place there, so now that guy's in. And we'll get the other one here. Just a little bit of pressure, snapped in. So then this guy will tighten. I need to take this guy off here. This is your fixed jaw in the middle. It doesn't move. I believe this wrench does it. This is my first time doing this. That seems to be it. I think. Take these little inserts out. These just keep chips from getting in the jaw or in the hole. That's it. So these locate, so when I put this back on, I won't have to indicate it in or anything. This is a tightly held diameter here, and then it goes into the mating part here. So pull that off. Stick the new one on. Bolts down in. Tighten it up. These jaws came with new rubber gaskets, so I'll use the new ones. I'll keep these with the other. there we go. That's now we got a fresh set of jaws to machine. So now spin it around. Do the same thing on this side here. Alright, so now I'll swap these jaws out and then I'll get ready to post my program. Okay, so now what I'm going to do is I need to find what's called my work offset. So my program is based on a point that's at the top of this block and then the very center of this block. And what this probe does is I'll tell it to go ahead and find that point, so then the machine knows where to base the program off of. So I'm essentially going to use this, I'm going to probe this block, and then it'll tell me exactly where the top and the center of this block is. So what I'll do, something over here, go to edit. Now I'm going to do a rectangle block. I want to put it in G54, that's my work offset, that's fine. I want it to probe Z, so I want to hit yes. Z surface, so I want to tell it approximately where the probe is. I need to come down like minus 0.2 should be fine. My X direction I know is roughly 4.35. So that's the X length it's looking for. That block is about 4.35. My Y is roughly 4 inches. So this direction here, it's about 4 inches. And then how far do I want the probe to come down? I'm going to do minus 0.15. Should be fine. So now when I press start, I should go ahead. Probing Z. Now it's probing in the X direction. It's going to find the center that way. Now it's going to find the center in Y, and it'll go back to center. Okay, so now if I come over here, go to my offset page, look at G54, it's my X, Y, Z position. The only other thing I need to do is I'm at A and 90, so I need to come over and just manually tell it 90 point. Now it's saying, make sure you want to put that big of a value in. Yes. Okay, so now I'm at 90 degrees. Alright, now that we found our work offsets, now I need to load my tool, which I just loaded in the spindle here. It's a 3/8 aluminum end mill. Well, it's not made of aluminum, it's for cutting aluminum. I don't want to mislead anyone here. So I need to now measure this tool so the machine knows where the tip of the tool is. So to do that, we use this tool setter over here. So what we do, go back to our control, edit, and we want to go back, we want to go tool offsets. Now I just want to do auto length. One tool, it's tool 21, and if I just press cycle start, it'll feed down and it'll come and it'll touch, and after it touches, okay, now if we come back to the offset page, when we look at tool 21, it now has a length offset. So that tool is now ready to go. Alright, if you take a look here, the first tool ran, and everything looks pretty good. You can kind of see it starting to take shape here. While this was running, I went ahead and I programmed the rest of it. So what we're going to do is I got a couple more tools to load up. I'm going to load the rest of the program in. We're going to let this thing finish up and see what happens. Alright, so as you can see, our second side jaws turned out great. I'm very happy with how these turned out. So what I've done is got a little ahead of myself and didn't film the first little bit of this, but I loaded my actual top cap program into the machine, and I ran my first tool here. I just run one part for now to prove it out, and you can see starting to take the shape of a top cap. The reason I stopped it here is I just wanted to let it rough while I had to build a couple more tools and get them ready to go. So one thing I want to show is I'm switching to a new thread mill from Harvey Tool, which is that company there. I use 90% Harvey and helical tools on my razors. I think they just provide a good product and great website, great social media presence. So my thread mill that I typically use is this guy, which it's hard to see on a GoPro, but you can see that it's a single form thread mill. So this has to start at the top and spiral all the way down the threaded post. So this is an old one, but it spirals all the way down the post here. So the nice thing about a single form is it can cut multiple pitches. So it can cut a 1024 or a 1030. Alright, my battery died there, but as I was saying, switching thread mills from the single profile, which is this guy. So this guy has to spiral all the way down, but he can cut multiple pitches. He can do a 1024, 1032, what have you. This is called a multi-form or a full form thread mill, and it is actually, it has cutting flutes. This has a 1/2 inch length of cut. So this drastically reduces the amount of turns I have to make with this. So really, with my part, I can just do essentially, you know, almost just one turn. I'm going to do a couple just to make sure I'm not leaving any material, but this will drastically reduce cycle time. So I'm looking forward to trying this. This is the first time I've used a multi-form or a full form thread mill. Now, this can only cut one type of thread, so this is a 1032 thread mill, whereas this could cut multiple pitches. This guy here is strictly for 1032, but that's what my razors are, so that works out. And you can buy these in any pitch and size that you want. So yeah, I'm looking forward to giving this a try. So I'm going to load these tools up, and then we're going to run the rest of this operation. Alright, so I got those 6 additional tools loaded. I'm searched down to where I left off, so I'm on this 1/8 inch end mill. So I'm going to bump my feed rate down and back up to tool change. What I have to do is I have to adjust that coolant nozzle so it's hitting my tool or close to it, and now I can set that in the offset page too. Cooling off, go to single block, and I got 2 inches to go. Looks good. Say we're in the right area there. I'm gonna let it go, see what happens. Alright, this tool will run for a little bit. We'll just gonna run the tools through and see what we end up with at the end. Alright, so the part just finished up, and at first glance it looks pretty good. I'm gonna get it out of here, do some inspection on it, make sure it looks good. And if it does, I'll make any changes I need to make, and then I will load up the whole pallet here and let it run overnight. So I'm gonna take a look, and then we'll see if we're ready to run a whole pallet. Alright, so everything on that op 1 checked out pretty good. I decided before I go ahead and run an entire pallet of op 1, I'm going to go ahead and prove out op 2. So as you can see here in Fusion, I got my op 2 soft jaws in here. And because these are so close together, and my jaws aren't quite wide enough, I have to treat them as essentially one piece of stock. So my first operation roughs 2, so I can only work in multiples of 2 right now on my second op, which is okay. So I can turn this station on and this station on over here individually, which, like I said, it works out fine. So what I'm going to do now is I'm going to load this program up. I'm going to load 2 parts in this first station here. I'm going to let it run, and then we'll check it out and see how op 2 goes. Alright, so the program just finished up here. Let's take a look and see what we have. Yep, those look really good. I'll get them out of here and make sure all the blends and the chamfers and everything match up, but the logo looks nice. I'm using this Harvey, it's a 2-flute tapered engraver. It's a great tool. I engraved all the base plates with it, and it's still rolling on the top caps. So yeah, that looks really good. I'll get them out of here, and then the next step is, if those are good, I'll find my work offsets on the other 3 stations, and then get my program set up to, I'm going to run essentially a full tombstone. 12 here, 12 op ones on the backside, 4 and 4, which should, I'll get a better estimate of a cycle time here in a minute, but that should be anywhere from 18 to 20 hours of unattended runtime, which is perfect for me. So, alright, let's see how they look, and then I'll get it loaded up. Alright, so program's loaded. As you can see, tombstone is completely loaded. 24 first operations, 8 second operations. So the program, I have pallet 1, pallet 2, soft jaws 1, soft jaws 2, all set to on. Calling my sub programs, so we're going to fire this thing up. Hopefully it does the right thing. The axis has to unwind here, so I just wound it around a bunch of times. So one more trip around the sun, and then this thing's gonna go. Alright, slow it down. Make sure it's coming down in the right spot, which it seems to be. Alright. Oh, so far so good. It's in the right spot. It should be in good shape. So we'll come back in probably 18 or 20 hours and see what we have. Alright guys, so that pretty much wraps up the process of making our top caps. I'm sure, you know, as we go here, we'll evolve the process, make some changes, improve our processes. But as you can see here, we cranked out quite a few top caps over the last couple days. It's all unattended runtime, which is great. The machine can run while I'm away. And again, as you can see, they all look nice. Everything, all the threads check out. So what we'll move on to next is our base plates, and then just keep proving out our components on the new machine. But again, you know, thanks for watching. Make sure you subscribe. We're going to try to keep doing more videos as we progress here. And again, thanks for all the support.